All right, let's look at three kind of more interesting problems that have a little bit more work to them or a little more thought process to them. Number 22, 1 over x squared plus 5. So this is a rational function. And that means we know that x squared plus 5 cannot equal 0 for our domain. So if I subtract 5 from both sides, that means x squared cannot equal negative 5. So there's no way to get take a real number and square it and get a negative number back out. That's just not possible with real numbers. And so that means there's no value I can plug in here to work this out. And that then means that the domain is all real numbers. So if there's no way to solve this, there's no answer or solution there, then we go back to looking at all real numbers as being our domain. Number 23, I have the sixth root of x squared minus 16. So this is an even root. And what I need is x squared minus 16 to be greater than or equal to 0, which means x squared has to be greater than or equal to 16. And then as I look at this, there's some sort of x, I don't know, is greater than or equal to plus or minus 4. Okay, so there's something kind of weird going on with this problem. Let's draw a number line so we can kind of work our way through and figure out what's going on exactly. So it looks to me like the numbers of interest here are this plus or minus 4 that we would get out of solving this. So let's go ahead and put those on here. And then we're going to look at some test values kind of within these intervals and see if that helps us to get some intuition on what's going on. So if I chose x is equal to 1, is 1 squared greater than 16? No, nope, it's not. So that means nothing in this interval is really going to help us out. I mean, you could go through and plug in a bunch of numbers in here and kind of verify that for yourself, but nothing in here is going to work for us. Let's look at x is negative 3. So if I take negative 3 and square it, I get 9. And 9 is not bigger than 16. So this part here is also out. What if I chose something like positive 5? So 5 squared is 25, which is greater than 16. So that means we like this whole area here, the positive side. And the same thing, if I plugged in, say, a negative 6, negative 6 squared is 36, which is bigger than 16. So this side over here also looks really good. And then let's just double check on 4 and negative 4. So if I put 4 in, I get 4 squared is equal to 16. So that does work. And then same thing with negative 4. So when I look at this then, my domain for this is x is greater than or equal to 4 for over here. And on this side, I have x is less than or equal to negative 4. So that domain has two parts to it. Right, and then the last one here, number 24, I have 1 over the square root of x plus 2. So this is a combination of a rational function, because we do have the fraction, and this even root. Okay, so we have two things going on, a rational and an even root. So the rational function tells us that square root of x plus 2 cannot equal 0. That's going to be a problem in our domain. And that even root part of this says that x plus 2 has to be greater than or equal to 0. So we're going to put these two things together. Okay, so I know it can't equal 0. That's the only restriction here. And this is that it's greater than or equal to 0. So I can combine these two together and say x plus 2 has to be strictly greater than 0. So I can't have it equal to 0, but anything bigger than 0 is going to work. So I can't put x plus 2 less than 0 because that'll give me a negative number under this root. We can't do square roots of negatives. So that means I end up with a domain of x is greater than negative 2. So any value I plug in that's bigger than negative 2 will keep the denominator from being 0, and we'll make sure that this even root has a positive number inside of it. So there's our domain.